Okay, so today we are going to deep dive into something you've definitely seen a lot online,
Eh?
instructional animations.
Right,
These are
yeah.
those moving graphics that try to explain, complex things like how an engine works or like a whole ecosystem, how that's balanced.
Yeah. I mean, they're really everywhere these days in education. The idea is to really make learning about these complex systems clearer than just static pictures.
Right. I mean, it feels like they should be better, right? Just movement in and of
Ugh.
itself. You would think that would make it just easier to get. But here's the thing, and this is kind of a curveball. When researchers have actually compared, learning with these animations versus, learning from just still images, the results are kind of all over the place. Sometimes they're great, sometimes they're no better, and sometimes they can even be worse.
Yeah, yeah. No, you're absolutely right. And that's a really good point to keep in mind. I think the problem often comes down to animations can sometimes be too much. There's too much going on, it's too fast, and it ends up feeling like you're trying to drink from a fire hose. Just too much information.
Right, right. And that leads us to, I think, the real core of what we want to deep dive into today, and that is this idea of cueing.
Yeah.
So think of this like um, a way to guide your attention when you're watching an animation, right? We're not talking about adding more information, but actually using things like visual things like size and color and movement to help you, the learner, to zero in on what's really important, see how the pieces fit together, how it connects to stuff you already know. It's almost like, when you're reading and you use a highlighter.
Exactly, exactly. And what we really want to unpack in this deep dive is how these cueing techniques, which seem to work really well in like text and static images, how they translate to this world of animations, right? What makes them work or not work when you're trying to learn from something that's moving. And I think that's what we're really going to get into today.
Yeah, and I think for you, the listener, who wants to learn quickly,
Uh-huh.
right, but you don't want to be overwhelmed. This is kind of like your cheat sheet. We're going to go through all the complexity and hopefully give you some real insights into how you can get the most out
Yeah.
of these animations. So let's start with just like the basic question. Why does learning from animation sometimes feel like so much work? Why can it be so tiring?
Right. Well, I think there's a couple of core reasons for this. And the first is kind of what we touched on earlier, right? Animations, they're transient. The information's there and then poof, it's gone. Unlike a diagram that you can sit and look at for as long as you want, with an animation, you're constantly trying to take in the information, process it, make connections to, what you just saw and what's about to come, and all while it's literally disappearing in front of you. So that puts a huge strain on your working memory.
Right. It's almost like you're trying to build a Lego set, but the instructions are disappearing every couple of seconds.
Yeah,
You have
yeah.
to like hold that image in your mind while you're trying to also understand, the bigger structure and how it all connects to other stuff. So no wonder it's tiring.
Yeah, absolutely. Absolutely. And the second challenge, I think, is just how dynamic many of these animations are, right? You often have multiple elements moving, changing all at the same time. So it's like this competition for your attention. And there's a lot of research that shows that dynamic elements, things that are moving, or appear suddenly, they're incredibly good at grabbing our attention.
Right. So even if that particular movement or like a flash of color isn't important to like actually understanding the core concept, it can still draw our attention just because it's visually prominent, right?
Absolutely, yeah. You might find your eye drawn to something bright or flashy or something that moves a lot, even if it's not really relevant to what you're trying to learn. And that's really where good instructional design comes in. Using tools like the cues we've been talking about to actually help you focus on the information that really matters.
Right. So it's
Yeah.
it's not enough to just make an animation move. We need
Hmm.
to think really carefully about how to guide the learner's attention. So this takes us back to cueing.
Right.
How do we understand from like a theoretical perspective how this actually helps us learn?
Well, I think to really understand how cueing impacts learning, we have to think about it on two levels. One is, how our eyes and brain kind of initially take in the visual information, how we see things. That's kind of the perceptual level.
Yeah.
And then how we process that information in our minds to build understanding. And that's, more the cognitive level.
Okay. So let's tackle the perceptual side first.
Yeah.
What does research tell us about what grabs our attention visually?
Well, our visual attention is fundamentally selective. We can't focus on everything that's in front of us all at once. We only really focus on a small part. And what we do focus on is often determined by how much certain elements stand out, right? And researchers like Schnotz and Lowe's, they make this really helpful distinction between what they call visuospatial contrast and dynamic contrast.
Okay, so break those down for us a little bit. So visual spatial contrast, that sounds like something that kind of visually pops out at you, right?
Yeah, exactly, exactly. When something stands out because it has different visual characteristics, maybe it's
Mhm.
bigger or different color or shape than everything else. Whereas dynamic contrast is about something grabbing your attention because it moves or it changes over time. It creates a visual event.
Okay, so a bright red object in a sea of blue objects,
Hmm.
that would have high visual spatial contrast.
Yeah, yeah.
And something that's suddenly like spinning, that would have high dynamic contrast. Yeah.
Exactly, exactly. And a lot of research and visual search kind of supports this. Distinctive features like that unique color you mentioned, they can make an object pop out and grab your attention, almost automatically, even if you're not even really looking for it, right? So studies have shown that unique colors and differences in brightness, luminance, contrast, they're particularly good at this.
So this kind of reminds me of those Where's Waldo books.
Yeah.
Waldo has really high visual spatial contrast because he's the only one with those stripes.
Absolutely, yeah. That's a perfect example. And then you've got the role of time. So things that change suddenly or things that appear unexpectedly, what researchers call temporal discontinuities, they also grab our attention, especially if they happen quickly. So the work of Jones and Yantis has been really important in showing how these abrupt onsets really pull our focus.
So if like a new part suddenly appears in a diagram or something,
Yeah, your eyes are going to be drawn to it. Yeah.
our eyes are going to go right to that.
And then you have Franconi and Simons, they propose this idea of a dynamic default hypothesis, which basically says that, any dynamic event, the start of movement, something moving, something getting bigger, something appearing from behind something else, it tends to get this priority in our attentional system.
It's more noticeable to us.
Yeah, absolutely. However, and this is an important caveat, research by Hillstrom and Yantis suggests that motion only really attracts attention when it helps to segment an object from its background.
Okay, so just random wiggling might not do it.
Right.
But if an object starts moving against a still background, that's more likely to grab our attention.
Yeah, exactly, exactly. And what this all means is that, even without any added instructional cues, things like bright colors and obvious movements in an animation, they already have these inherent cueing effects.
Yeah.
They're naturally going to draw the eye. So when we talk about instructional cues, like arrows or highlighting or things like that, we have to think about how those work alongside the natural attention-grabbing features of the content itself.
Right. So knowing this, we could actually use these attention-grabbing features to maybe reduce distractions.
Yeah. Yeah.
Right. Like dimming down a color that's really bright, but it's not important, or maybe like subtly flashing an important part of the image, right?
Exactly. So by strategically playing with these visual features, we can potentially make, unimportant elements less noticeable and really guide attention to what matters.
Okay, so that's how we initially like see and attend to things.
Right.
Now let's talk about the cognitive side, right? How does cueing affect how we actually learn and understand?
Yeah, so this is where things like Mayer's cognitive theory of multimedia learning and Sweller's cognitive load theory come into play.
Right.
So Mayer's theory basically says that meaningful learning happens when you select the important information, you organize it into a logical structure, and then you integrate, you connect it with what you already know. And all this is happening, in your working memory.
And we know that, working memory is like, it's like a limited mental workspace.
Yeah.
We can only hold so much information at once.
Exactly, exactly. And that's where cognitive load theory comes in, right?
Yeah.
So it helps us to understand the different kinds of mental effort that are involved in learning. So you've got intrinsic load, which is, just the natural difficulty of the material itself.
Okay.
You've got extraneous load, which is the unnecessary mental work. This is the work that's imposed by poor design. So that might be like constantly having to look back and forth between, some text and a diagram that are placed really far apart.
Right.
And then you've got germane load. And this is the effort you're putting in to actually understanding the material and building those mental connections. So that's the load that leads to actual learning.
So that's the good kind of load.
Exactly.
Yeah.
And so the goal is to minimize that extraneous load.
Right.
So we free up more mental resources for that deep understanding, that germane load.
So it's kind of like having, a really clean and organized desk.
Yeah.
So you can focus on the actual task at hand.
Yeah, exactly. Exactly. And complex animations that can create this really high cognitive load, especially during that initial selection, organization, and integration phase. And what cueing can do is it can help to reduce that extraneous load, especially the effort that's involved in visually searching for what's important. If your attention is guided effectively, you just spend less mental energy hunting for what's important. And that frees up your working memory to actually build those mental models and understand the material.
Right. So it's like having, a good tour guide in a really complicated museum.
Yeah.
Right. They're pointing you to the important exhibits so you don't get lost and overwhelmed.
Absolutely. Yeah, that's a great analogy. And there's research to back this up. Studies have shown that cues in text can reduce the mental effort that's needed to process it. There's research that has found that reducing cognitive load with cues can actually lead to a deeper understanding, that aha moment that kind of sticks with you.
Right.
There's even evidence that things like color coding in multimedia can reduce cognitive load and improve learning. However, it's worth noting that some studies have actually found that cueing leads to better learning without necessarily seeing this measured decrease in cognitive load.
Huh. That's interesting. So maybe the main benefit of cueing isn't always about like directly reducing the mental strain, but actually making our mental processes more efficient.
Yeah, I think that's a very valid interpretation. So the general idea is that queuing often streamlines that visual search process,
Right.
which allows your working memory to then focus on those core tasks of learning.
Okay, so we understand the why and the theoretical how of queuing.
Yeah.
So let's get practical now. The research that you mentioned actually proposes this framework of different functions of queuing based on Mayer's learning theory. So what are those functions?
Right. So we can broadly categorize queuing into three main functions,
Okay.
each of which is designed to support a different part of the learning process. So those are selection, organization, and integration.
Okay, so let's start with selection. That sounds like it's all about zeroing in on what's important, right?
Yeah, exactly. So often, especially when you're new to a topic, you might not know what information in an animation is, absolutely crucial and what's just kind of background. And so the function of selection queuing is to emphasize particular information to clearly indicate its relevance. It's like putting a spotlight on the key elements.
Okay.
So examples of this might be, using different colors or underlining. So for instance, if you're learning about how an engine works, a selection cue might highlight the piston that's currently being discussed.
Okay. Okay.
Yep.
And has research shown that this kind of queuing actually works, in static media like text and stuff?
Yeah. Yeah, there's actually quite a bit of research on this. So studies on reading comprehension have consistently shown that, cues improve our ability to remember the cued content. And interestingly, it doesn't necessarily mean we pay less attention to the uncued parts. Some research suggests that we actually process the cued information more deeply. For example, there have been studies that have found that when something's highlighted in text, people actually spend more time reading that section, indicating this kind of more focused processing. So emphasizing the information can help us to select what's important, and it improves our retention of it.
That makes sense. I mean, if something's visually distinct, you're naturally going to kind of pay more attention to it.
Yeah.
What about when we're trying to solve problems visually?
Yeah, so the principle seems to hold there as well. Research on visual problem solving has shown that when critical elements in diagrams are highlighted, people are more likely to find the correct solution. And similarly in instructional visuals, using things like color or motion
Yeah.
to guide attention to key information has been shown to improve learning. So it seems like emphasizing information helps us select what's important and improves both our recall of that information and our ability to solve related problems.
Okay, so function number 2 is organization.
Right.
So how does queuing help us to see that big picture and see the structure of the information?
Well, understanding isn't just about, memorizing individual facts. It's also about seeing how those facts connect and form a coherent structure. And so the organization function of queuing aims to help you accurately represent the underlying structure of the information that's being presented. And without those organizational cues, it can be really hard to kind of see the main topics and how they relate to each other.
Hmm.
So for instance, in an animation showing a complex process, organizational cues might visually group the related steps together.
Okay, so in like a complex animation, this might be like showing how different parts of a system fit together, or
Yeah.
maybe like the sequence of events in a process.
Exactly,
Yeah.
exactly. And in text, we see this through things like, outlines, headings, topic sentences.
Right.
And research shows that these cues can lead to, faster reading times for the important structural elements, better retention of those main topics and how they're organized. They can even influence how you organize the information in your own memory. However, it seems that these cues are most helpful when the material is complex and doesn't have this obvious, well-defined structure.
Okay. What about in more visual media? How do we cue organization in those?
Yeah, that's actually an area where the research is a little bit less developed, especially when it comes to dynamic visuals. So static visualizations, they can show structure through how things are arranged spatially.
Right.
So for example, in a diagram of the solar system, the arrangement of the planets shows their relationship to the sun. In graph comprehension, the way the information is structured visually impacts what we understand.
Right.
But then when you add this element of time, like in animations, showing that structure can become much harder. Think about trying to show the assembly of a complex machine, but you're just using a static exploded view.
Right. Right.
You often need things like numbers or arrows to indicate the sequence.
Right.
And interestingly, there hasn't been a lot of in-depth research on organizational cueing in static visuals that involve this temporal element, let alone animations.
Right. So while we know these organizational cues are helpful in text and basic illustrations, how to best apply them to dynamic visuals is kind of still a work in progress.
Yeah, exactly. But the underlying principle is that, by helping learners to see the structure of the information, it should improve their overall understanding and retention.
Okay. And finally, we have the integration function. This sounds like it's about connecting the individual pieces and seeing the relationships between them.
Yeah, absolutely. So building a truly coherent understanding, it requires you to grasp the relationships between different pieces of information,
Right, right.
the cause and effect steps in a sequence and so on. And so this function of cueing, it focuses on making these complex relationships more noticeable.
Okay.
And we can actually break this down further. We can talk about relationships within a single representation. So like within the animation itself.
Okay.
And then relationships between different representations, like between an animation and some accompanying text or narration.
Okay. So let's tackle that within a single representation part first.
Right.
So how can we cue relationships just within that one animation?
Right. Well, in complex texts or illustrations, related ideas or parts might be really far apart, which makes it, difficult to kind of see how they connect.
Right.
And without, some sort of guidance, your working memory can easily get overloaded trying to make those links. And research on text processing has actually shown that using cross-references or explicitly stating causal links with relational cues can improve memory and your ability to apply what you've learned, particularly for well-defined causal systems. However, if the content is kind of simple and the connections are obvious, then these cues may not be as necessary.
Okay. So it's really most helpful when the connections aren't super obvious, right?
Exactly. And in visualizations, and especially animations, information about how things function, or the sequence of events or cause and effect, it might be implied rather than directly shown.
Right.
And research on static pictures has actually shown that, trying to figure out these dynamic aspects from a static picture can be really demanding.
Yeah.
It creates a high cognitive load.
Right.
And that's why things like graphical cues, arrows, lines, things like that, are often suggested to explicate those, unclear causal relationships.
Right.
And the goal here is to highlight the sequence or the temporal connection,
Okay.
not to just, point to a location. So studies have shown that these graphical cues can lead to more functional interpretations, a better understanding of how things work. And even verbal cues can help with this, especially for learners who maybe aren't as strong with spatial information. However, it's important to remember that just adding relational cues, it doesn't always guarantee that learners will actually grasp the underlying cause and effect mechanisms.
Right. So we need to be thoughtful about how we're using them. Okay, so that makes sense. Now, what about relating elements between, different ways the information is presented? So like an animation with some text that goes with it.
Right. So when you have, an animation and some accompanying text, you're constantly needing to kind of look back and forth and connect elements between the words and the visuals.
Hmm.
And if you've got a lot of interacting parts, this back and forth can make learning a lot harder. And so cognitive load theory suggests that, physically integrating those things, putting the text and the visuals closer together,
Right.
or presenting them in different modalities, like combining visuals with spoken words.
Yeah.
These things can reduce that need for mental integration. But even when things are presented in this really integrated format, you might still struggle to see which parts of the text correspond to, which parts of the animation. And so that's really where relational cueing between representations comes in. The aim is to, really explicitly link those corresponding elements so you can build this integrated mental model.
Okay. And what kind of cueing techniques are used for this?
Well, a variety of techniques have been tried. So things like, briefly flashing the related elements in the animation and the text at the same time, or giving them the same color, or using orienting cues like gestures or gaze, where someone's looking in a video.
Right.
And these have often been shown to have positive effects on how well you remember the information and how well you can use it. However, the impact on really deep understanding, that ability to transfer what you've learned to new situations, that's been a little bit less consistent.
No.
And the effectiveness often seems to depend on how complex that visualization is. And research on interactive media has also shown that things like, connecting lines and hyperlinks can be effective relational cues. So in general, these cues do seem to help you remember the information, but their impact on truly understanding it deeply can vary and might depend on how complicated the material is.
So this is all fascinating in theory, but what does the actual research on cueing, specifically in animations, tell us? You mentioned that there's been a lot of intuitive use, but also some actual studies looking at this.
Right. So while the general idea of guiding attention in animations makes intuitive sense, one researcher referred to it as this attention guidance principle.
Right.
The evidence from the research is somewhat mixed.
So mixed how can we go through some specific examples of what researchers have found?
Yeah, absolutely. So let's start with some of the studies that have shown, beneficial effects.
Okay.
So one study in 2001 looked at how people learn about airplane lift. And they found that verbal cues, so things like changes in the speaker's, tone of voice or pitch,
Oh.
these things actually help people to apply what they'd learned to new situations. However, visual cues like arrows and icons and color, these things weren't effective, and the researchers suggested that this might be because the animation that they used was actually too simple. So maybe the complexity of the animation is a factor in whether or not these cues are helpful.
Yeah, that's an interesting point. Maybe simple animations just don't need that much guidance.
Yeah, it's possible. It's possible. Another study in 2005 looked at how people learn about gears. And they found that, both visual cues using color and verbal cues, so text labels, improved how well people understood and remembered the information. And this was particularly true when they could control the animation themselves.
Okay.
However, in this study, it was kind of hard to separate out the effects of those different cue types, Was it about guiding attention? Was it about making relationships explicit? It's hard to kind of tease apart.
Right. Sometimes it's hard to know exactly why a cue is working.
Yeah, yeah. So then you have a 2003 study on how enzymes work, and they found that nonverbal cues, so things like color, arrows, and actually visualizing the terms being used, this improved learning. But in that case, visualizing the terms might have added more than just attention guidance. It might have actually provided additional information about, what those terms mean.
Right. Right.
And then in 2007, you have researchers studying the cardiovascular system, and they found that, using color contrast as a cue, this improved both how well people understood the system and how well they could apply that knowledge. And interestingly, this was true for both the cued and the uncued content.
Hmm.
suggesting that effective cueing in a complex animation can help you to use your working memory more efficiently.
Right.
And this supports this idea that visual cues might be most helpful when the animation is actually complex. So another study in 2008 looked at a pendulum clock, and they found that simply increasing the speed at which the animation played, this actually acted as a cue.
Okay.
And it led to people more frequently and correctly mentioning, less conspicuous but relevant parts of the animation. So this shows that manipulating the timing of the animation can also act as a way to guide attention.
Right. So it doesn't have to just be, visual. We can use, speed and things like that as well.
Yeah, and then that same research team, they actually compared animation speed to arrow cues.
Okay.
And they found that speed change was actually more effective at directing attention and improving learning.
Interesting.
So maybe dynamic contrast is kind of more powerful than visual spatial contrast.
Okay.
And then finally in 2007 you have researchers looking at a piano mechanism. And they found that this continuous kind of spreading color cue that was synchronized with the causal chains, this improved understanding of the kinematics and the function of the piano, and possibly by altering the viewing patterns and increasing cognitive processing. So this kind of cue was kind of serving this dual function,
Yeah.
both guiding attention and making the relationships between the parts explicit.
Okay. So we've seen some examples where verbal cues, visual cues, even these temporal cues, like the speed of the animation can be beneficial.
Yeah.
But you also mentioned some studies where the cues didn't seem to help. What was going on in those cases?
Yeah, and these are really important to understand as well. So
Okay.
so in 2007, researchers studying a toilet flushing mechanism, how a toilet works,
Right.
they used arrows to kind of guide attention and emphasize the causality, but they found, no benefit on comprehension tests,
Yeah.
even though eye tracking showed that people did actually look at the arrows. And in 2009, the same research team, again looking at the cardiovascular system, this time they used a spotlight cue that did effectively capture attention. Again, the eye tracking showed people were looking at it, but it didn't consistently improve understanding. So this finding really suggests that just getting someone to look at something, it's not always enough for them to really understand it.
Right. So just because our eyes are on something doesn't necessarily mean our brains are processing it,
Mm.
in a way that leads to understanding.
Absolutely, yeah. And another study in 2007, this showed a list of skills being taught alongside an animation. And highlighting those skills in the list, this didn't actually improve learning,
Huh.
possibly because it forced people to kind of split their attention between the animation and the list, and the highlighting wasn't really sequential.
Okay.
So then in 1998, researchers they added text captions to an animation about the cardiovascular system.
Yeah.
And they found, no improvement in understanding,
Right.
possibly because the existing labels in the animation already provided the necessary information.
Right.
So the captions were kind of redundant.
Right.
And this really highlights that, the cues you add need to work with the existing elements of the animation.
Right.
And then in 2007, researchers tried highlighting a part of an animation and putting a dot next to a corresponding sentence in the text, but it didn't help. And this is possibly because the link between the cue and the concept wasn't really specific enough. It wasn't clear. So these studies really suggest that visual cueing in animations, it doesn't always lead to this deep understanding, this ability to infer causal relationships, and might only affect these more kind of surface level processes like identifying and selecting things.
Right. So it's clearly not as simple as just adding a visual cue and
Mm-hmm.